Okay, the question here tells us to circle the expressions that is not equivalent. So basically we're looking at the expressions. We're not solving it all the way. Now for A here it says 37 times 19, which I can interpret that as 37 19s or 19 37s. So 37 19s would be equal to that expression. The next one says 30 times 19 already here, and we're going to subtract this value from it. So obviously this one here cannot be equal to our expression. The next one says 37 times 20 minus 1, which would be 37 times 20 minus 1 is 19. So this one here would also be equal. And our last one, if we simplified it, would be 38 times 19. So this one would not be equivalent either. Going to B. Now this one here, once again, we can say 26 35s or 35 26s. So 35 26s would be equal. Going to the next one, even if we were doing distributive property, we would see that we end up having to multiply these, and this could not be correct because this would end up being 56 times 31. So this one here is not equivalent. On our next one, we're doing 26 times 30 plus 26 plus times 5. So basically just doing distributive property. If I go 26 here times 30, because I'm splitting the second factor, plus 26 again, which is the same factor, times the rest of the 5 for 35. So this one here is equal. Our last one says 35 times 20 plus 60, so that's going to be 35 times 80. So this one here also cannot be equal. Our last one comes up being 34 times 80 plus 9, which would be 34 times 89, which is equal. Our next one goes 34 times 8 plus 34 times 9. This is the most common mistake students make when they do distributive property. They start out outright going 34 times, but instead of saying 80, they go 8, because it should be 80, but they forget the 0, plus 34 times 9. So you can see in their example down here, they forgot the 0, so this one here would not be correct. The next one is 34 times 90 minus 1 is 89, so this one's equal. And our last one says 89 34s. That is equal, because I could express this as 34 89s or 89 34s. Okay, on 2 it says solve using mental math, draw a tape diagram, and to fill in the blanks to show your thinking. The first one is partially done. So you see what they've done. They've drawn a tape diagram for us. And up top we're saying this 19 times 50, so this is 19 50s. And you can see what they've done. They've drawn a tape diagram of 20 50s, because 20 50s are easy to multiply. So 20 50s would be 20 times 50. And since we're solving for 19 50s, we're going to have 20 times 50 minus 1 times 50. So 20 times 2 times 5 is 10, and we got 2 zeros, and 1 times 50 is 50. So when we subtract that, bringing up 950. On the second one, it's telling us 11 times 26, so we got 11 26s. And we're trying to solve for 11 26s. But when I'm thinking about it, something easy would be 10 26s. But I need one more 26, so I'd be plus 1 26. So 10 26 plus 1 26, that'd be 10 times 26 is 260. 1 times 26 is 26. When we add them together, it'd be 286. Now the tape diagram would be like so. And the way I like to draw them, no tape diagrams are really wrong. It says 11 26s. So I know this is a 26. This is a 26. And there's 11 of them. And I know I want to add one more 26 to it. So this would be 1. This here would be my 10. And this is my 11th 26. Our next one goes 49 times 12. And I can see it's saying 12, so it's going to be 49 12s. Now, instead of looking for 49 12s, I'm thinking it'd be easier to go with 50 12s. And since I'm really looking for 49, I'm going to solve for 50 12s and then subtract 1 12 from it. So that's going to be 50 times 12 minus the 1 12. I have to get back to 49 12s. Now 50 times 12 is going to be 5 times 12 is 60, and then I have an extra 0 minus the 12 I have here. Then I have 600 minus 12, and we're going to subtract. We have to regroup, and I end up with 588. So we know 49 12s is 588. Our next one says 12 times 25. That means there's 12 25s. Now, the same thing here. I'm going to go to an easy number to multiply, which is 10 25s. And then I need to add 2 more 25s. So it would be 10 times 25 plus 2 times 25. 10 times 25 is 250. 2 times 25 is 50. So our answer is 300. Now, I forgot to draw my tape diagrams up here, so I'm going to go back to it. So this first one, I'm going to draw it. And I'm saying 12s. So I know this is a 12. I know this is a 12. And I know there are 49 of them. Now, this is 1. This is 49th 12. And this here is my 50th 12. So I'm solving for the 50th 12, and then we're going to subtract it. The next tape diagram, we actually solved for it was 12s, 25s, I mean. Write that down, 25. Here's a 25, and there were 12 of them. Now, on this one, we actually subtracted 2 of them. Excuse me, added 2 of them. Let me redraw that. So we solved for the 10. So these were 25s. And we solved for 10 of them. And then we added 2 more 25s. Because this was 1, here's the 10th one, 11, and 12. Our next one says 29 times 12. That means we have 29 12s. So I'm going to go ahead and draw 29 12s. There's a 12 here. There's a 12 here. And I know there's a total of 29 of them. But when I solve, I'm going to solve for 30 12s. And that means that actually I'm going to change this to 30. Sorry. 30 12s. And I'm going to subtract 1 12. Let's put the next one out here so we can see it. So this would be 1 12. This is 29 12s. This is 30 12s. And we're subtracting 1 of them. So that'd be 30 times 12 minus 1 times 12. Well, 30 times 10 is 300. Well, 3 times 12 is 36. Then we're going to add a 0. Our next is 1 times 12 is 12. So now we have 360 minus 12 becomes 348. Now our next one, we have 31 11s. So here, I'm actually going to solve for 30 11s. And then I'm going to add one more, because there's 1, 30, and 31. Because that's what we're actually looking for, is 31 times 11. Well, 30 11s plus 1 11. So 30 times 11 and 1 times 11. Well, 3 times 11 is 33, times 10 is 330, and 1 times 11 is 11. So we're going to add them together, we get 341.